Now that we have this large family of empowered teachers, students and colleges through our eYantra labs, we have the capability out there in the field of a community now which can go out into the real world and it can look at problems and actually think of solving those problems using the resources that they have in the eYantra labs. So we asked ourselves, what is a different arena, a different theatre which has similar qualities? It should demand robustness in your offerings, it should demand ruggedness in your products, it should be able to absorb a lot of technology like image processing, robotics, drones, what have you. It should be able to work in a very hostile environment in terms of physical environment, being away from energy sources, from communication infrastructure and things like that. So we looked around and we thought that one wonderful such arena is that of agriculture. Now agriculture is not only an interesting arena, it's a very interesting problem to solve and requires a lot of innovation in this country, and it's a wide open field for innovation. And if you look at it, our entire country is almost a greenhouse. India has always been a culture of abundance because wherever you walk, you can grow stuff. Given the fact that in a couple of decades, almost half our population will be living in metropolis regions, wouldn't it be nice to start using the open spaces there to grow food? Couldn't we then create a situation where older people, say retired people, can look after, if you like, these urban farms and be helped in this venture by young people who are at college and school who actually build and maintain the technology in these farms? And thereby we had the start of this wonderful idea of urban agriculture. And what you see around us here and behind me now is our urban agriculture test bed, which is technology and methodology which we are going to share with each of the 240 and growing number of eYantra labs that we built in the country. And this is going to be the basis for not only technology development, amazing BE projects, but the source of innovation and entrepreneurship to produce wonderful products and in the process create a vibrant ecosystem which can turn ideas into products and services and amazing technology.
When we started this urban agriculture testbed, there was a challenge like there should not be any leakage. Then we wanted to keep our agri input cost very low, so we choose organic farming where we use Amrit Mitti as a growing medium. And now we have a 4,000 square feet of farm where we have like 18 to 20 different rows where we grow like spinach, tomato, okra, cluster beans, amaranthus. There are some climbers also. Plants need like timely irrigation. They don't need much water. So for that we need to automate the irrigation system.
So we initially started with a wired system having a central power distribution box. This system did not require any frequent repairs. However, the initial installation was cumbersome. Hence, we upgraded it to a wireless system which was powered using batteries which could last at least for a month. Both these implementations were controlled via web interface.
I am currently developing the backend framework for our greenhouse and terrace farming system. We studied different IoT systems and we found that the requirement of our system is totally different from the normal home automation system. Our current system is able to handle common activities such as drip irrigation system and the collection of the data from various sensors connected to our greenhouse. We also found that the current system is able to detect new devices which is installed on the greenhouse and is able to perform various activities such as the scheduling of those devices and the visualization of the sensor data on the timely basis.
Like what we have here is a space is a form of a small balcony at a normal household, wherein drip irrigation can be automated using this low-cost hardware and a small drum wherein you can fill water and schedule and remotely actuate the pumps inside this drum to water the plants.
I have worked on the sensor development for the irrigation system. As we know that for growing the vegetables in these test beds, watering is one of the major tasks. So for automating this irrigation system, we need some sensor feedback, and that's why we are developing these sensor nodes. And what major parts of the sensor node is the capacitive sensor, which measures the soil moisture, and other major part is the wireless sensor networks.
The most essential part for this sensor is communication. All the sensors are worked wirelessly, that is deployed in the field, and they collect the data and transmit it to the main server. So we design on the transceiver circuit. We are testing in it, which works very well, and we are very soon we are going to deploy this transceiver into our greenhouse.
Currently I am designing a sensor network using ZigBee module. It uses a MSP 430 board for low power options and CC2530 module, which is a low power ZigBee module developed by Texas Instruments. The idea here is to integrate the developer sensor node with a sensor such as temperature, humidity, soil moisture attached to the microcontroller, which transmits the sensor data to the central server, which is on which can be a Raspberry Pi or a central server, and record these data and then plot it and obtain like what is the kind of what is the temperature, what is the humidity, and what are different parameters and how the things are working.
We get plenty of harvest from this terrace farm, and we actually distribute this among our faculty members and staff. We wanted to actually distribute or sell this product on online basis, so we have developed this one product.
So once we have such terrace farms ready, which are producing different fruits and vegetables, we have the problem of monitoring the farm produce and the harvest, and coming up with a viable distribution channel for selling or distributing such fruits and vegetables. So we thought of a solution in which a weighing scale is connected to the internet for logging data. It also has the capability of capturing the image and user selectable inputs like which fruit or vegetable is placed on the weighing scale. We also have a bare bones version of an e-commerce site which takes data from the weighing scale, stores in its database, and gives you a feel of what is the available quantity of the produce on a particular day. Now the user can log into the site and view what is the harvest and order accordingly.
We've seen our two test beds, one in the form of a greenhouse and one as a terrace farm on the terrace of the computer science department. With this project, we are trying to establish yet another test bed, but this time this can be inside your lab where you're working. So this test bed involves growing plants under LED lights. Plants require only red and blue light for photosynthesis. So what we have done here is we have bought a low cost LED strips of red and blue each and arranged it so that we are able to achieve photosynthesis for the plants. Our system is just like a Firebird, which comes in the form of a lab in a box. This system is like a farm in a box where we have sensors such as temperature sensor, humidity sensor, soil temperature sensor, CO2 sensor and ambient light sensor to sense various parameters inside the box, and we have fans and lights which are schedulable so as to mimic the same effect of a natural environment of day and night. So all the systems we develop, be it sensors or actuators, require power for them to run, and making them last for long using batteries was a bit difficult. Hence we were investigating other naturally available sources for harvesting energy to power these devices.
So the operating life of such IoT based or wireless sensor nodes depends upon its battery size and the power consumption of the sensor node itself. Typically such IoT based applications are deployed in outdoor or remote environments, and regularly replacing their batteries will add up to the maintenance cost, particularly if the number of such sensor nodes are quite significant. So it is essential for such IoT-based applications to make such IoT-based applications more prevalent and scalable. It is essential to look into different alternative sources of energy so that the sensor node can scavenge energy from its ambient environment. Now, some alternative sources of such energy are solar, which is photovoltaic, ambient RF energy, piezoelectric, which is obtained from vibrations. Now, out of these available energy, alternative energy sources, solar is a viable option considering its cost, its potential to generate power, and the use of off-the-shelf components. So we are trying to make this design power supply circuitry such that we are able to extract maximum power from low capacity, small form factor size solar panels, which are connected to the power supply circuitry of the sensor node itself.
So another application that we are working on is load monitoring for greenhouse appliances. Greenhouse require various kind of appliances like irrigation pump, fogger, cellulose pad, fans, etc. Right now, the system which exists, in that we have to go to the field and control these devices manually. Our objective through this system design, through this application, is to have a remote control of the appliances, remote monitoring of the appliances, and also measure the power consumed by these appliances.
The future may be summed up by this acronym CAST, C-A-S-T. C stands for cloud. We see increasingly that there's going to be more and more cloud infrastructure and what people refer to as IoT, which is sensors deployed around us and feeding information into computing infrastructure in the cloud, and people making and taking interesting actions based on the sensed events. And this is a wonderful platform for checking out IoT in the context of farming. A for automation. Automation is a very broad word. As we need to increase our production in an exponentially growing economy, we have to use technology. We need the equivalent of having automated autonomous plowing machines, seeding machines, harvesting machines, but indigenously made. S, sustainability, the most critical thing of them all. Sustainability, global warming, climate change is going to make it very difficult to keep business going as it used to be in the past. So we have to look at technological initiatives and interventions to improve our growing of food, and this is a wonderful test bed with which to experiment with these kind of technologies. T is tools. There are going to be more and more hardware tools, software tools, more and more tooling to extend what a single individual can do. So CAST, this is what we believe is the future, and we believe that this urban farming test bed will grow all the skills required for young people to develop those technology capabilities, which tomorrow, if needed, can be deployed in other domains. So that is the basis for the inspiration behind the eYantra Urban Farming Initiative, to train youngsters in technology, give them real problems, build real skills, and grow an innovation ecosystem. All this is for the benefit not only of the youngsters, but for the country. Jai Hind.